What happens when you accidentally register the same resource URI twice in your FastMCP server? Should it silently overwrite, ignore the duplicate, or fail fast to catch potential bugs early? We'll configure a FastMCP server to explicitly raise errors on duplicate resource registrations, then demonstrate how this prevents accidental overwrites. You'll see exactly what error message appears when attempting to register a second function with the same URI, and how this behavior helps maintain clean resource organization. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals resource server. OnDuplicate resources equals error. Hash raise error on duplicates. At MCP resource, data//config. Def get config v1, return version 1. Hash this registration attempt will raise a value error because hash data//config is already registered and the behavior is error. Hash at MCP resource, data//config. Hash def get config v2, return version 2. This demonstrates the resource registration pattern with duplicate handling policies, a core concept in FastMCP's resource management system. Resources act as read-only data endpoints that clients or LLMs can query, with URIs serving as unique identifiers. What makes this distinctive is the declarative registration combined with configurable conflict resolution, allowing precise control over resource lifecycle management. The pattern works by treating resource URIs as immutable contracts, where each registration attempt is validated against existing entries based on server configuration. When OnDuplicate resources is set to error, the system enforces strict uniqueness by rejecting duplicate URIs at registration time, preventing accidental overrides. This design creates a self-documenting resource layer where the URI namespace remains predictable and conflicts are caught early during development. This approach solves the common problem of resource namespace pollution in dynamic systems, where accidental overrides could lead to runtime inconsistencies. It's particularly valuable in collaborative environments or when building resource-heavy applications where URI stability matters. The trade-off is stricter development constraints, but the benefit is a more reliable resource graph that clients can depend on without versioning surprises. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable resource servers. It provides the foundation for registering and managing resources that AI models can query, ensuring clean separation between implementation and interface. MCP equals FastMCP. This instantiates the core FastMCP server, the central orchestrator for all AI-callable tools and resources. The configuration here defines global behavior, like how duplicate registrations are handled. Name equals resource server. This names the FastMCP instance for debugging and logging. A clear identifier helps trace resource conflicts and server events in production, especially when running multiple MCP servers. OnDuplicate resources equals error. Hash raise error on duplicates. This configures duplicate resource handling to raise a value error immediately. Prevents silent overwrites when registering the same resource path twice, and forcing explicit version control. Critical for maintaining predictable resource resolution in production systems. This closing parenthesis finalizes the FastMCP instance initialization with the specified duplicate resource handling policy. It locks in the configuration that will raise errors on duplicate resource registrations, enforcing strict resource uniqueness. At MCP resource, data//config. def get config v1, return version 1. This registers get config v1 as a resource at the URI data//config. The decorator pattern binds the function to FastMCP's resource system, making its return value accessible to other components via the URI. This is how FastMCP implements resource registration and dependency injection. This registration attempt will raise a value error because data//config is already registered and the behavior is error. At MCP resource data//config. Def get config v2, return version 2. This commented out code demonstrates FastMCP's duplicate resource protection. When onDuplicate resources equals error is set, attempting to register a second function at the same URI raises a value error, enforcing strict resource uniqueness. This prevents accidental overrides in production systems. Resource registration control. FastMCP's duplicate handling policies let you enforce strict uniqueness or allow flexible overrides, with 4 distinct behaviors for URI collisions. The default warn mode silently replaces resources while logging, which can mask accidental duplicates in production. Choose your policy based on whether you prioritize safety or flexibility during development.
The URI that refuses to change becomes the anchor for all versions that follow.